Alright, so integration by parts. This will be my fifth example. Alright, U and V are differentiable functions. Then the integral of u dv is equal to uv minus the integral of v du. And the dv, we want to let it equal the more complicated function, provided that there's an integration rule for that function. Okay, so let's take a look. Alright, so here we have sine cubed x dx. Alright, so we don't have a rule. I'm sorry, not sine, but I think I said sine cubed x, secant cubed x dx. We don't have an integration rule for secant cubed. Alright, and to do this, if we look at secant cubed x, what do we have in secant cubed x? Well, what if we rewrite this as secant squared x times secant x dx? Well, we have an integration rule for secant squared. So all we're going to do is we're going to take the secant cubed and rewrite it as secant squared times secant. So here I'll let dv equal secant squared x dx. So that means that v is equal to the integral of secant squared x dx, which is just equal to tangent x. And so that means u is going to be secant x. So u is secant x. So du, and do you remember this formula? That's what? Secant x tangent x dx. Alright, so now we're going to do integration by parts. So we've got u dv is equal to u times v minus the integral of v du. Okay. So let's go ahead and write the problem again. Alright, so secant cubed x dx, that's going to be u times v. So u times v. So that's going to be secant x tangent x minus the integral of v, which in this case is tangent x times du, and du is secant x tangent x dx. And so this is going to be secant x tangent x minus, and so we've got secant x times tangent squared x dx. I just multiplied the tangent x together. Alright, so if we look at this, there's really not anything we can do here, because, I mean, we can't use u substitution, because if we let u equal tangent, then what happens? Well, the derivative of tangent is secant squared. That doesn't give us this. Alright, so maybe what we can do is, how about, let's rewrite tangent squared as secant squared x minus 1 dx. Remember your rule that says 1 plus tangent squared x is equal to secant squared x, and then if we move the 1 over, we get tangent squared x equals secant squared x minus 1. And so we replace the tangent squared. See, tangent squared is secant squared x minus 1. Alright, so let me get rid of this. Alright, and then let's go ahead right here and distribute the secant, this secant x here. And so that's going to be secant x tangent x minus, and that's going to be secant cubed x minus secant x dx. Alright, so here let's go ahead and split this up, because, well, I don't really know anything about secant cubed x, but I do know the antiderivative of secant x. So this is going to give me secant x times tangent x minus the integral secant cubed x, and then now this minus is distributed, so that's going to be, I left my dx off here, and the minus and the minus, that's plus secant x dx. Okay. Alright, so what are we going to do here? Okay, not really a whole lot I can do here, and actually you see this secant cubed x. I'm right back to this. Okay, so let's do a little trick here. You see this secant cubed x dx? Alright, so our problem was secant cubed x dx. Okay, that's what this equals, all of this. So secant cubed x dx is equal to this, is equal to secant x tangent x minus the integral secant cubed x dx plus the integral secant x dx. Alright, so what can we do here? Well, what if I add the integral of secant cubed x dx? What if I add that to both sides? Well, that's going to give me 2 I'm sorry. That's going to give me 2, okay, because this plus this is going to be 2 integral secant cubed x dx equals secant x tangent x, and then that's going to be plus, because these go out, plus secant x dx. Okay, and so now I get 2 times the integral secant cubed x dx equals secant x tangent x plus, now for this part right here we have an integration rule. Okay, and so that is going to be the natural log, the absolute value, secant x plus tangent x plus c. Okay, alright, and then what I'm going to do is I'm going to get rid of this 2, because see, I just need to know what the answer is to secant cubed x dx. So I'm going to multiply through by 1/2. And so the 2's cancel here, and so I get the integral secant cubed x dx is equal to, so 1/2 times this is 1/2 secant x tangent x plus, and then the 1/2 times this is going to be 1/2 natural log absolute value secant x plus tangent x absolute value, and then the 1/2 plus c, well, that's just going to be another constant, so I just leave it as plus c. And so this would be our final answer. And I hope this video's helped. Hope you'll check out my other videos, and if you like them, you can subscribe. All right, thanks.